I decided to make a video about this and to actually stream it live. And essentially, this is a blog post which I want to read, and all the work and all the effort and all the credit is going for the creators of the blog post and not me. The idea of this video and stream is to just read it, try to learn from it, and then maybe come up with potential ideas for the future to extend our lab, extend our weaponry, and pretty much become a better red teamers. Now, this book is about using WinRM plugins for lateral movement. Now, I did not go before the stream over it. This is going to be my first time, so I'm doing it live. Let's see how it goes. TLDR, I mean, we just started. In this blog post, we explore how to leverage WinRM plugins to perform lateral movement on other systems. So, I hope you're hearing me well. If you have any questions, I'm gonna make sure I jump to the chat as much as possible so we can communicate and answer these questions. But for now, let's just move on. We also take a look at how the CIM underscore log file WMI class can be used to bypass directory detections by Microsoft Defender. Finally, we put all the logic together in a Cobalt Strike BOF. This looks promising. Now here, it's not clear to me if we're using MD, the EDR, or just the Defender itself, but I think we're gonna get this going soon. Context. One day I realized I did not have any Cobalt Strike BOF to connect to WinRM. Now WinRM is usually used for lateral movement over PowerShell. It's called Windows Remote Link, and pretty much it allows you to run PowerShell commands over HTTP endpoints. Tools that can be helpful here are either WinRM or manually creating a peer session and connecting to a specific host. This can come in handy when you steal token from a high privileged user and want to connect to another system using WinRM. Now that's extremely important because usually when you steal a token from someone, you have mainly two options of connecting, two main ones. Of course you have many more, but two main ones. The first option is pretty much the WMI exec, because the WMI exec uses WMI, which is going to actually save the context of the user. So when you connect, you're going to see your new shell as your current user instead of a system. And also WinRM is the next option because WinRM also uses the context of the same user. So if you want to sustain your privileges and your rights, definitely go for WinRM or WMI. Now, certainly an alternative way to do this would be to dump POSAS, get the hash from the high privileged user, and then pass the hash together with something like either WinRM via SACS. However, I think the last approach has a higher chance of being detected. Yes, the main reason is first, the LSAS dumping could be detected. Second, pass the hash and either WinRM is also going to be detected, especially if you did not do any modifications to the WinRM. Just by connecting to WinRM only, doesn't matter if it's from stocks or not, you're going to be detected. So yeah, determined to fill this missing bit of tradecraft, I went straight to the Microsoft documentation about WinRM and started looking around. With some readings, I discovered the following repository, that's interesting, with multiple examples provided by Microsoft. Okay, Microsoft Windows Classic samples, WinRM, Shell Client API, WS Man Shell plugin, Man Olds plugin. That's nice. Okay, one of them consisted of a client to interact with the WinRM shell, so I decided to port this example to a BOF. You can have a look at the final code here, so it's already inside GitHub, so we can take a look at it, and it's a BOF code. Nice, okay, perfect. I'm not sure if, I think that's a Cobalt Strike BOF. I think the BOFs for Cobalt Strike are kind of different from the other C2 framework, but this I think can be ported pretty much easily. Of course, I have to spend time to have a better look on Google. I would have found two other examples of WinRM BOFs here and there, but then I wouldn't have discovered WinRM plugins. Yeah, this is the pretty much the benefit of it. Okay. Some expectation management up front. To interact with WinRM, you need admin privileges on the target system. Therefore, everything explained here will assume you have such rights. Okay. About WinRM plugins. According to the Microsoft documentation linked here, WinRM offers an API to accept third-party plugins. Okay. This plugin consists of a DLL that needs to be located inside the system32 folder. To use a plugin, first it needs to be registered in the system with the following command. So WinRM create plugin schema, I believe. That looks like it. Minus file plugin XML. The XML that needs to be passed looks like that. So we have plugin configuration, name, file name where we can pass DLL, SDK, XML rendering, architecture enabled, and some more parameters inside the XML file. This XML defines multiple properties such as location of the DLL in the system32 folder. So it's a no-go, it must be inside this folder and nowhere else. The URI which we use to call the capabilities of the plugin supports. Depending on the capability supported, the plugin will also need to implement certain methods. The Microsoft documentation details these methods required to implement a plugin with shell capability, similar to one that is used when you use the winrs.exe binary to execute commands on a remote system. I didn't use that before, but maybe I give it a go. You can even try very nice example of this type of plugins in this Microsoft repository. Okay. However, these types of plugins are at first glance pretty complex, and implementing a lateral movement technique seems a bit of overkill. My intention was to implement the minimum expression of a WinRM plugin, where its main function is loading shellcode. In that case, a plugin with only a get or put capability would be enough. Unfortunately, I wouldn't find any documentation to implement this type of plugin, not even the methods that needs to be exported in the DLL for these basic capabilities. Now that's super smart, because if you go for a plugin instead of the main WinRM, I think you're gonna be more stealth, just because that's something unexpected, and I think it's pretty nice job that someone thought about that and tried to implement it. Built-in WinRM plugins. By looking around on the internet, it doesn't seem very popular to develop WinRM plugins. So what about already installed plugins? That's maybe a nice idea. Funnily enough, the WSMan configuration is exposed as PowerShell drive, which allows you to enumerate the plugins registered in the system. Okay, yeah. So if you go to get PS drive, I think these are the plugins. ls wsman localhost. Now there it is, the plugins. Okay, so that's how you can enumerate WinRM plugins. Okay. Here we see that the base install of Windows already included several WinRM plugins, and some familiar names like PowerShell for PS Remoting are there. But where's all the information saved? Running Pros Monitor uncovered the following while enumerating WSMan with PowerShell. We have registry keys, they're saved inside registry, guys. There it is. Going to the location in the registry, we see a very familiar structure. WSMan, wasn't it a structure of, for example, that? It seems that most of the WSMan configuration, including plugins, is stored in these keys. In fact, Pros Monitor will show new keys being created in the same location when you run WinRM create something. Register a new plugin. Taking a look at the associated data of one of the plugins showed that the config XML key stored. The manifest for the plugin, for example, in case of PowerShell plugin for PS Remoting, from the registry we can see the XML file, which has the same template as the one above. There is the DLL, the schema, version, and so on. Which logically has a shell capability. Looking at the exports of pwrsh plugin.dll, we can see it exports a very familiar set of methods. These are the same function implemented by the demo WinRM plugins and the one already documented in the Microsoft knowledge base. So with dump in, this is the one from the Visual Studio development console. You can just see the exported functions from any DLL, and by running that, we can see these exported functions. What about the other plugins? So let's analyze an additional one. The Microsoft Windows Server Manager Workflows plugin uses the same DLL as the PowerShell ones. Would that mean there are other ways to natively interact with systems via PS remoting beside the PowerShell command? Definitely interesting, but that's one thing to check in the future. Looking at the last two plugins, Event Forwarding plugin only has the subscribe capability in the manifest, which has a bit discouraging. However, the WMI provider implements almost all of them. Okay. So essentially how I see the things is that in the XML file, the configuration of each plugin, you have the options and settings, which is called here capability, of what the plugin can do. And with these capabilities, you can pretty much do some actions. Like I think the invoke is for the PowerShell. But let's see. And these are the exports for the WSM WMI PL.dll, which is the DLL provided here. And funny thing, it should always be inside this folder. So the exports are WSMAN plugin shutdown, create, delete, enumerate, get, invoke, put, pull events, and so on. This function has not been documented by Microsoft, and looking for them on Google and GitHub doesn't return any interesting results. Does that mean we are in the correct path, finding something cool? Maybe or maybe not. Deeper look into WSM WMI PL.dll, descending the binary in IDA and taking a look at that specific export WSMAN proof put, we see how it first called the constructor of TSTR buffer and adapter parameter classes. So this is the IDA disassemble. So let's try to analyze what it does, although it said so. It calls constructor of two classes, so it is initiated to new objects. One of them is from this TSTR buffer, and the other class is adapter parameter class. So in that case, this will be the adapter parameter, and this is the TSTR buffer. So it creates two objects. Okay. Then it interacts with WMI to update the records via the put XML to sim object and get XML from sim object functions. There it is. And before ending, it calls these functions related to WSMAN, get VSMAN data, VSMAN plugin object results, and VSMAN plugin operation complete. Okay. This last call is documented, and it reports the completion of an operation in the WinRM plugin. Therefore, it seems straightforward to implement the put capability in a plugin. Most of the action observed above doesn't seem to require for our case. We just need to make sure we call WSMAN plugin operation complete before returning from WSMAN prof put. Just one detail is missing: the function prototype of WSMAN prof put. Unfortunately, this one can be obtained by descending the WSMSVC.dll. So I think the creator means to say that the main idea is to create a WinRM plugin which is capable of doing two things: get and put. And in this get and puts, we can pretty much, I'm not sure how this is gonna end up working, but I think we can see that later in the blog post. And to make this possible, he disassembled one of the already established plugin with these capabilities, and found out that in order to create a plugin with these capabilities, we would need that. And by disassembling that, he can find a function. There it is. I think I get it so far. I think I get it so far. Yeah, hi, nice to meet you. But let's see how it goes. Minimal WinRM plugin. With all this information, we can already compile, a very basic WinRM plugin. We want to put the main logic of the shellcode folder inside, vsmon provider put, and then vsmon plugin startup, and vsmon plugin shutdown needs to be there. Since they are required for any WinRM plugins, okay, that's important. At this point, you may ask, why go through all the effort to look for another function? Why not executing stuff in DLL prost attach, within DLL main, or even vsmon plugin startup, maybe because of folder lock, let's see. The reason are firstly to avoid folder lock, exactly, and secondly, looking at the documentation for the vsmon plugin startup, it seems that this function can be called multiple times, which isn't something we want. Yeah, so because if you do that, your payload can be called different times, which can essentially make it to fall apart and break and shut down and kill the process and so on. Then if you do something like that, you need to somehow make sure to use, what was the terminology? To ensure that your payload is running only one time, you can use things like mutex to ensure that the payload is running just once. But I think it's better to not do that because it can cause waterlock issues. Now the DLL main looks like that. This is the DLL main. Then we export the function we want via sman plugin startup. Okay. Inside this plugin startup, we have two string objects, one int object variable. We have plugin context. Okay. We export another function, the shutdown one, which I think is documented. And we export the put. Now on the put function, we can call our, yeah, there it is. Yeah, so this is gonna ensure that when the put function is executed, this wsmon prof put, then and only then the shellcode would run inside and not in any other steps. So the creator of the blog post realized that this function is called multiple times, which can, as mentioned, break the process and so on. We don't want to execute the shellcode inside the element to avoid waterlock, and essentially we want to execute it here. After compiling, we must copy the DLL to see Windows Test System 32. Yep, the name of the DLL doesn't need to be something specific. For example, in this case, it is another WinRM plugin.dll. Now it's important to make this, to know that inside the manifest. So in the manifest.xml, we have the name as here, and also the path as like that. Now, the important here is the capabilities thing. So we have resources URI, the standard, and there is capability type. Now we don't have get capability here, I think. It's just put. Yeah, it's just put. So these methods are essential for the WinRM plugin. They are needed. We have also, of course, the DLL main because it's essential for the DLL. And beside that, we have our put function, so no get. And then execute this WinRM command, WinRM create, specify the schema, define the name to be the plugin itself, and then the file with this manifest XML. Then we have the output, resource created, reference URI, resource URI is that. Everything looks normal. If we take a look at the registry, we see how a new key has been created. Yep, there it is. But that's on the local system, right? So we have system A, system B. On system A, you have a token for some user for system B, but when you do so, this plugin will be created on system A, so we still need to do something. Before covering our plugin, we must first restart WinRM service, restart it, and finally, we call this plugin with WinRM. Just note you need to pass an empty XML file. The contents can be as simple as a tag. WinRM, put, specify the plugin, and contents. Thanks to debug view, we see the output debug string calls. Okay. One thing to notice is that the vsmon plugin shutdown has not been called. After a quick look at the docs, it seems this is only called when the plugin DLL is unloaded. After some testing, restarting WinRM caused this function, nothing that really affects us now. Okay. In Process Hacker, we see how WinProhost TXE is the process responsible for loading and executing WinRM plugin. It seems this process will be running even after a successful call to the bot method. However, restarting the WinRM service will nicely exit this process, which triggers a call to VSMAN plugin shutdown. Okay. Lateral movement BOF. At this point, we have only need to program a lateral movement BOF with a WinRM plugin. To make it operational friendly, the BOF can be divided into the following three main actions. First one is going to be install the plugin. We're going to register a WinRM plugin to interact at this level with WinRM. You need to use COM programming, and I just couldn't make it work. There are two possible solutions for this. Guess what I choose? Proper solution, worm COM programming can make it work. Short-term solution, technical debt, enable and start remote registry via SE Manager and create the keys with create keys X. So you can use Win APIs, and if you have admin access over a specific system, you can use some Windows APIs to interact with the services, to interact with the SE Manager, and essentially create a binary that's gonna change a registry key from a remote system, and that's what the creator of the blog post is doing. But he showed out in that the proper way of doing that is to learn COM programming and do all of that by COM. So, but still he finds a workaround which is super nice. Copy over the file to the system32 folder with create file and write file, and then stop remote service and restore its configuration to default. BOF command, beacon, WinRM plugin jump. Is that a native command inside the Cobalt Strike? I don't think so. WinRM plugin jump, action install, hostname up1, and DLL as the DLL. Oh, that's the BOF itself. Yeah. Then we call the WinRM plugin. Now we just need to call the pod method for our WinRM plugins. This time I managed to do it via COM. We don't have any other choice. Below I described the main calls that needed to do this action from C. As you may have guessed, I am far from having any experience in COM programming for now, so any constructive feedback is very welcomed. The point is, I'm in the same situation. Initialize COM for the current thread and create an instance for the VSMAN class. Okay. H result, HR equals to co-initialize EX. CLS ID from string. Okay. Yeah, I cannot give any constructive feedback because I'm still not good at COM. Then use the create session method from the object psman, pwsman. We connect to the remote server. There it is. Create session, connection URL, so on. To expose and to be able to call pod method, we first need to query a pointer to the session object with query interface. I'm not sure from where he gets the CLIDs. Are they standard? Are they hard-coded in each system? Do they have the same name? Or I'm not sure. If you guys know about that, just hit me up in the chat. And then we finally make the call. Okay. There it is, pf session pod, resource URI, resource data, flags and results. Yeah, COM programming doesn't look that fun. Then the BOF command, WinRM plugin jump. So I think Cobalt Strike has this. I think I'm not sure, but this can be either a BOF command from which was compiled to Cobalt Strike, or this is a built-in Cobalt Strike command to interact with WinRM plugins. But based on the file, on the text before, I think this is just the compiled BOF command. Action call, hostname up1, okay. And then uninstall the plugin before forgetting about the systems. We need to clean all the mess, the changes we made. Enable and start PS remote registry via SC manager and delete the keys which were previously found. Restart WinRM service. Keep in mind that doing this will cause all beacons running with WinProv host exit to die. And then delete the DLL from system32. BOF command, WinRM plugin jump, action uninstalled, hostname up1. So this WinRM plugin jump is pretty much the... There it is. I think this is the one. This is the... No, it's not. There it is. WinRM plugin jump. This is the WinRM plugin designed for Cobalt Strike to interact with this kind of WinRM plugins. So it's the source code is there. You can take a look at it, but this is what this WinRM plugin jump actually is. It's a compiled BOF. You can find the code from the WinRM plugin, post the BOF here. Oh, yeah, we just need to read it one more statement. Never mind. Okay, conclusion. Using WinRM plugins, we managed to successfully perform whatever movement in stealthy fashion. This is the newly discovered technique which allows you to, oh no, is detected by Defender twice. Now I think this is the MD. This is not interface for the Defender antivirus. This is for sure MD. And let's see what MD has found. DLL search order hijack. So we have services, SVC hosts, DLL search order hijack, and that's it. Which is good because MD didn't flag WinRM or the home interaction, but it flagged the DLL itself. So it's thinking we do some kind of a DLL hijacking, which is not the case. So I think this can be fixed. This can be bypassed. In fact, it's worse. This was one of few built-in alerts I ever faced that took longer to trigger. It took more than 1 hour to appear from the moment I executed the action, making me think I crafted something that is not detected out of the box. To be honest, it shouldn't have been that surprising, the detection trigger. Taking into account we do all kind of nasty things to the targeted system. From the OPSEC point of view, exactly, we just interact with SC Manager, we create a DLL, and we store it as an admin on System32. So this is what was detected indeed. Interacting with services, copying files System32 over the network via shares, etc. So that's the detection point. Seems like a lost cause, doesn't it? Maybe that's why no one ever wants to touch WinRM plugins. But wait, how? The plugins we compiled for WinRM can be made less malicious. It just exports these three functions, plus it only calls output debug string and vsman plugin operation complete. WinRM plugins, although not widely used, are documented and meant to be used. Surely they must exist in a way to implement a plugin that doesn't trigger an alert from the same company that designed them. Looking back, which makes a complete sense. Looking back, for the dirtiest thing we have done so far is to copy files remotely using C-share and to System32. I can't imagine how many legit software installs or updates do that. Let's take a look at the file events collected by Defender to see how this activity is reported. So we have device file events, where timestamp is 1 day ago, device name contains VS1, file name contains WinRM plugin, and project reorder, time generated, action type, device name, and so on, which gives us these results. Yeah, there is another WinRM plugin. Sent authority system. ORSMB share name C. As you can see, file created operation contains the property share name. This is viewed if it happened from a share. In our case, C share. This makes sense since we used URI like ///vs1 //c share and so on to copy files remotely. So in order to make this the demo before, you need to first copy the WinRM plugin, then install the WinRM plugin using the BOF, and then trigger the WinRM plugin again using the BOF. But here the detection point is not the triggering of the BOF of the WinRM plugin, but the installation because the file was copied to the system in the first place. So what if we repeat all the steps detailed above, except the file copy operation to system32? In our attempt, we do that last step via RDP, 2 hours later. And after more than 2 hours, nothing triggered on Defender. Nothing bad and looking promising, but how do we do this remotely? Because in that case, we just copy paste our RDP. Moving files locally but remotely with sim logic file WMI class. Looking in Google for WMI tradecraft, I found this post. Okay. Copying files with WMI PowerShell. Whoa. That looks so nice, by the way. We can make a video about it. And also, and also we can, and also we can try to copy that into ADS, into alternative data stream. That's so nice. I'm not sure if that's gonna work, but I think it should be possible to copy a file using this WMI class inside ADS. But I'm gonna research on that additionally. Then from the guys at 40 North Security, it's a straight to the point post which basically explains how you can perform copy operation via the sim local file, WMI class. Since they already explained nicely how to work with WMI objects, I'm going to repeat it here again. With that, you can follow the strategy. First, copy the file to the ctemp directory, cshare, and then use WMI class to move it to its final destination at system32. So you're still gonna use, so okay, so to get it clear, we're still gonna use shares. We're gonna copy the plugin which needs to be installed over the shares to ctemp, and then use the WMI class to move it from ctemp into system32. Okay, which is the end is gonna avoid the create file operation, the create file event. Sounds good to me. Then let's take a look at how PowerShell commands would look in our case. File, get WMI object, class, filter, name of the file, which is the current file path inside ctemp, and then invoke WMI method, the file variable from there, copy arguments list, and inside C Windows System 32. Okay. A good initial sign about using this class is that you never work with shares. How so? So no reference to C $sign. Before proceeding and implementing this as a BOF, let's take a look in Defender to see how the operation is affected in the logs. So from here, select from sim local file where name equals the name of the plugin. It seems that Defender is capable to register WMI commands. Okay. We can now see how the first getWMI object is internally translated as a select statement. It's still visible, yeah. However, the copy operation only registers the source path. Oh yeah, there it is. It's the source path. ctemp. There is no remote path. In fact, it seems that this information comes from the moment you create the object, plus the destination path is not seen anywhere as part of this operation. Yeah, that's indeed. This means that unless some manual time-based correlation is done with file create events, this operation is invisible from the point of view of the defender. Something to keep in mind for the future. That's so important. Using this method, you can translate files with unknown destination. That's overpowered. Yep, that's overpowered indeed. Lastly, the file created event I mentioned before, which is performed by WMI prcv.exe, doesn't seem to indicate it was asked for another system. Copying the WinRM plugin to system32 via sim logic file, WMI class is definitely promising, but there's one problem. Interacting natively with WMI resolves RPC calls, which needs TCP135 plus an ephemeral port. Sorry if I pronounced that incorrect. This yet to exist water movement technique based on WinRM plugins already needs TCP/445 for service and file operation, plus TCP/5985 for the WinRM itself. Additionally, on top of that, a bunch of RPC interaction reduce the usefulness in the real environment even more. WMI via WinRM. But wait again. A couple of sections above, we export a plugin called WMI provider, which you guessed right, allows you to interact with WMI via WinRM. This came to my attention thanks to this post from Red Canary. Taking a look at the Microsoft documentation also helped a bit, so we can translate the PowerShell WMI commands to WinRM command like that. WinRM, invoke, copy, and then we specify schemats and here the WMI command. So that's crazy because now we can embed the WMI command inside the WinRM itself. Before porting this to C, or the BOF, let's take a look at the HTTP SOAP sent. By default, WinRM transmissions are encrypted, but you can use scripts like this to decrypt them. Wow. Nice. Or even better, in this scenario, you can change the configuration of the WinRM client and server to allow unencrypted communication. That's why you generally have two ports for WinRM, 5985, I guess, yeah, and 5986. 86 is usually used for encryption, 85 for not encryption. It can be achieved with the following commands to be executed in client and server respectively: WinRM set WinRM config client unencrypted true, and again service unencrypted true. Then after executing the WinRM invoke copy operation, we see the following HTTP messages in Wireshark. The wrong encoding is due to the fact that the body of the HTTP messages is UTF-16 encoded, while the HTTP headers are UTF-8. We define the body. Now here, selector set, selector as the selector name, we define the path to the local path to the WinRM plugin. So the first step, we send it over the shares to ctemp. Okay, that's why you define a ctemp and the plugin name here, the DLL. And then on the copy input, here we use the sim local file WMI operations to pretty much copy the file from the location which is designed here to the location which is C Windows System 32 and the DLL name. Okay. Calling the class invoke method via WinRM from C is very similar to the pod call explained before. The contents of the body from both needs to be passed in the parameters argument of the invoke call. So we have pp file, sim local file. We define the COM objects. We also translate everything to C now. So that's what we're doing. As you can see, this is the destination path. This is the WMI function to be called, and here we just use the invoke to call the function and call WMI from WinRM. And that's it. We can now perform the attack without triggering defender alerts. The final code of the BOF is here, same link as before. So it's already updated. Okay. Before finishing, a quick video showing how the BOF can be used to lateral move to another computer using this technique explained here. Some notes. The DLL used to get the beacon implements some evasion techniques to avoid being statically and dynamically flagged by the defender, which I haven't covered here. As far as I could check, calling non-malicious looking DLL should be good to go to use with the BOF. However, the DLL straight out of a Cobalt Strike will definitely be flagged, and that's something which is expected. Now let's see what happens here. So we have beacon, system, VS1, action. First we install, and we use users export def payload.dll. Now this is system A, from where we have Cobalt Strike, and we want to move to system B. Now on the system A, we run that, which is going to install this payload on system B. It's going to first send it over the shares, and then using the WMI method, it's going to move it to system 32. Then we have again WinRM plugin jump. We have system again VS1 and action call, which is gonna call the beacon, and in theory it should execute the payload, and there it is. That's quite impressive. That's quite impressive. Now detection. To detect this technique, we can look for DLL load events via WSM provhost.exe. That was a binary whose prevalence is below a certain threshold. For example, 100. Certain false positive can be expected if a non-built-in WinRM plugin is used in the environment. In this case, allow listing it should be enough. So this query can help detect such kind of attacks or lateral movement techniques. Here's the important part. We can even go one step further by correlating this to files dropped on disk. So essentially, this is the process which we want to monitor and scan for file interactions and so on. Then the folder path is going to be C Windows, assembly native images, I'm not sure what that is about. And also device file events. I think this is where we just scan events on file dropped on disk, but I'm really not sure. Thanks to Henry Ambersmian for creating this detection. A complete version of the detection is available on our Falcon Friday GitHub. Final thoughts, we leverage to WinRM plugins to execute code via DLL on a target system. As mentioned before, you need to be local admin on the system. Second, the use of logic file WMI class over WinRM save the day, and it's something to keep in mind to avoid similar alerts, especially in the Defender, but I think that can be applicable for most of the EDRs. In fact, it would have been good to explore how the service and registry operations involved in these techniques could be done via WMI classes, which also can be invoked from the BOF and from WinRM. This would free us from the interaction with the port 405, but that's something that may come in the future posts, and ChatGPT will surprise me when it comes to providing implementation example for common functions, but learning COM programming still needs to happen. Nice. Nice. Ooh. That was kind of a more advanced blog post, but it's a technique that I'm quite amazed of. Now, here we use WMI, WinRM, but not the standard ways of using WinRM like Evo WinRM and so on. But we use WinRM plugins, which is something Windows uses natively, and it's not that suspicious. Now, I think that's a really nicely done blog post. I give all the credits to the creators and a nice shout out and a great job, because this work is amazing, and I have to say massive thanks for providing this to the community. We also have the BOF implementation, open sourced, which is also a big deal, but the whole technique is just amazing. First, to make a nice summary of it, it uses a custom plugin with a custom payloads, which is a DLL, and inside this DLL you have a specific functions which are exported, and from the one of the functions you have your shellcode to be executed here. Now there you have a DLL, and here the important part is how you copy the DLL to the needed system. Now obviously you need to have some kind of an admin access, but how you copy that is by using WMI. So essentially you transfer the DLL first over SMB, then you call WMI to copy it to the system 32. And by doing that, you avoid detections. And after you do that, you can just use the invoke capability from your WinRM and just execute it and have your beacon. That's quite impressive. Whew. Yeah. Sorry if it was too boring, and let me know if you enjoy such kind of a content and such kind of a videos, because your feedback is much appreciated, and I see and reply to every single comment on YouTube and on Twitch and on Discord. I have to say massive thanks to my Patreon sponsors for supporting my work and making my work count. Thank you so much. If you have further appreciation, as they do, feel free to become a patron and get access to a lot of things like Shadowburn, my private packer, found my private mythic C2 agent, and a lot of different videos and projects which might be handy. Also, make sure to subscribe. Thank you so much. And if you want to support the channel, smash the like button, smash the subscribe button, which helps me a lot. With that, I think to wrap it up, thank you so much for watching. Thank you so much for sticking by. And I'm gonna see you into the next one. Bye.